All right, Algebra 2, we are on lesson 7-4. Today's date is Monday, April 8th, 2019. All right, so we just got back from our break. How you guys doing?
Yeah, I think I need another week.
I think all of us need another week.
I know. It's like barely Monday. It's barely 6 weeks.
Let's go ahead and take some notes. There is a general formula for this entire unit, and here it is. It's this thing. So let's go ahead and label some cool things about our exponential modeling function. This A right here, this capital A, that is your starting value. Starting value. So if you start at 2, A will be 2. If you start at 7, A will be 7. So this B, this capital B, there are many names for him. Some names are common ratio. That's the most common one that I know. So I'm going to call it common ratio.
Distracting me from learning.
Chris, are you okay?
No. He hit his knee.
Chris, we're taking notes. So that capital B is called the common ratio. So if I go up by 2 every time, if I keep multiplying by 2 and 2 and 2, capital B will be 2. That's however much you're going up by. And then f of t, that's just something's happening up there. And then you can kind of, I guess, underline the t. You'll have some t in there. The reason that this is an exponential function is because the variable t is in the exponent. That's why we get exponential. All right. So far, so good. We're still taking notes. And all right, so let's talk about the difference between exponential growth versus exponential decay. You'll be hearing these for the rest of the unit. So I need a volunteer here. What letter do we care about more if we're talking about growth or decay? Are we talking about A or are we talking about B? Quiet, raise hand. Eva, go for it. It is indeed capital B. For both of these, actually. So it's going to be capital B here and capital B down here. If I come back to here, that's the wrong thing. I was reading, what is this, manga? It's pretty good. Berserk is very violent, not school appropriate at all, but Eva is in Algebra 2. It is the #1 most popular manga according to I forget. My anime list. Can't say that.
Gio's almost dying.
Someone needs to heal Gio.
Whose group is Gio in?
Gio.
Okay, I was like, I'm so sorry.
Gio needs to be healed by Teflon. Teflon, you have full AP. You need to use that AP.
Okay. I guess I'll be nice.
All right. So when on the homework it's asking you, is it exponential growth or exponential decay? You will have to compare the values of capital. Chris, please stop. Are you about to untwist that? All right. So, if our capital B is between 0 and 1, so I'm talking about like fractions here. I mean, technically you can have a fraction that's bigger than 1, like 4/3 is bigger than 1, but usually the stereotypical fraction is like 1/3, 1/2, 1/7. If you have a fraction or something between 0 and 1, that is exponential. What would you guess? Quiet raised hand. Is it growth or is it decay? Is there a quiet raised hand out there, James? It is not growth, actually. 0 and 1, that's going to be a smaller value. So therefore, James, it is in fact decay. And I can't spell decay. There we go. Thank you, James. Let's come back here so I have it alphabetized. And there is James. All right. All right. And then finally, if B is between, I guess technically you can say 1 and infinity. So anything bigger than 1 I'm talking about here. Technically it could be less than 1, 2, but that's kind of weird. If you're bigger than 1, then it's quiet raised hand, easy XP here. Fiona. It is growth. Thank you, Fiona. That is our main definition for everything today, and we're talking about this formula. Okay, so let's do, I think I have 3 examples, and then we're done. Example 1. So I have an exponential function. Look, I have a starting value of 1,348. I have this common ratio of 5, 6. I have a variable in the exponent. It looks like an exponential function because it is an exponential function. All right, so that's going to represent the wolf population. That's getting changed every t months. I want to know what's happening every month with the wolf population. Is it increasing or decreasing? Let's go for a quiet raised hand. Actually, since it's binary, you can do thumbs up or thumbs down. Is it increasing thumbs up or decreasing thumbs down? Increasing or decreasing? Is it growth or decay? Increasing or decreasing? Let's see those thumbs. Eva, you can't do both. Most of you have it correct. It is decreasing. Decreases. All right, so that means if I'm talking about this word decay, it has a few words attached to it. Decreasing is one of them. Therefore, growth means increase. All right, there are two different ways that Khan Academy will tell you how it's increasing or decreasing. They will either say by a certain percent or by a certain factor. If it's by a factor of, like this case, it's a factor, it's really easy. Just tell them what the common ratio is. This is a common ratio of which one of these numbers, t things? Which one is the common ratio? Quiet raised hand. Just a quick review. Andrea? By a factor of 5, 6. Easy peasy, you're done. I bet that just with that one example, you could probably do 50% of the homework assignments in maybe 2 minutes. You could do them really, really quick. Okay. Example 2. This one I kind of squished two problems together to make sure that we know everything that's happening. All right, so now we have this function. It represents the amount of money of a stock market, or in the stock market. Maybe, I don't know, James, you're investing your money in the stock market very wisely. I want to know how much money you're increasing or decreasing, adding or subtracting to your original investment of $120. I originally invest $120 and it's being multiplied by 1.2. This one is harder. What percent is the money increasing or decreasing? I just want to know the percent right now. 1.2. What percent increase or decrease is that? Anyone want to take a guess? It's a harder question. Only one person is ready to go. James, go for it. You're really, really close. I'm going to take the second part of that. 20%. You had, I guess I realized that it's 120 and 1.2, which are similar numbers. I'm going to make a note to myself next time, use a random different number. This is to me, not to you. Use different number. Yeah, 20%. Here is the reason. You will always start with 1. Whenever you're talking about a percent. If I want to add on a percent, let's add on 5%. 5% is what as a decimal? Quiet raised hand. 5% is what decimal? Only 2 people know. 3 people know. Eva, go for it. 0.05. I will now add that to 1.05. This 1.05 multiplying itself over and over again is the same thing as an increase by 5%. Thank you, Eva. Yes. I'm telling you how to get from 1.2 to 20%. Yeah, so for example, if I have 1.39, what percent increase is this? Quiet raised hand. Gios, just say it louder. 39%. Okay. So a harder question now is this. What if I have 0.98? What's going on there, Fiona? So just like this is not 105%, it's only 5%. This is not 98%. It's something else. Not 8%. Gio? 9.8%. Not 9.8%. Good guess.
0.98%?
Not 0.98%. James? No. So it's always... Yeah. You're lost. You always start with 1. 1 is the magical number. And then from there you can either do one of 2 paths. Path 1 is you add a percent to it. Path 2 is you subtract from 1. What was subtracted from 1 to get to 0.98? 0.02. And 0.02 is what percent? So this is a negative 2%. So whenever they give you a decimal, always start at 1. I mean, the easiest way is just take that decimal and subtract 1. That's the basic rule. Like if I have the decimal 0.79, just subtract 1. That's a negative 21%. Just subtract 1. That's the answer. Subtract 1 and you'll obviously convert to a percent and you're good. So I'm just going to put that in red as a star. Subtract 1. Subtract 1 to get percent. All right, and is that adding or subtracting? That 20% of the money. I'm doing 20% of the 120 original investment that James put in the stock market. Is that 20% being added or subtracted? And again, you're thinking of growth or decay. 1.2, where is that? Is that in category 1, category 2, 1.2? 1.2, is that being added or subtracted? Added, thumbs up. Subtracted, thumbs down. Everyone vote. Okay, this 20% comes from 1.2. We can all nod our heads. We know how to get there. This 1.2, is that growth or decay? Growth means add, decay means subtract. Growth or decay, so let me see your thumbs. Everyone has thumbs. It's growth because it's bigger than 1. If it's between 1 and infinity or bigger than 1, then it's growth. This is growth, so it's being added. That means we can come back up here and add stuff to our notes. So decrease means subtract, and increase or growth means add. All right, so this is one phrase that they can use. They can say every year 20% is added, or they can say that the money is increasing or decreasing by a factor. Who can fill in these two slots for us, and it's almost exactly like this last problem, example 1. It's the easiest way that I can ask this question.
Wait, what was your question?
My question is, I want to fill in these two slots for example 2, and it's almost exactly like example 1, but with different answers, of course. James, go for it. There it is. Increase by a factor of 1.2. You don't even need to change anything. You just give it, or give what you were reading. 1.2, you don't need to change it. All right, so both example 1 and example 2 are from one homework assignment. The second homework assignment I can teach you in one example. Are you ready? I'm tired of reading. Someone read this to me for XP. Andrea, go for it.
The equation d of t equals 212 times 3/4 to the t over 3.1 models the temperature of water cooling off every t minutes. Then the temperature difference is reduced by a factor of 3/4 every.
How many minutes? Yeah, okay. So these are always talking about interpreting time. Thank you, Andrea. Beautiful reading. I want to reduce by 3/4, and notice that that is the common ratio. It will always be reducing by the common ratio. That will never change on the homework. So how do I get this to 3/4 to the power of 1? This 3/4 right here that it gave us is to the power of 1. How do I choose a value for t to make sure that this 3/4 is to the power of 1? And it's the easiest question that I've asked on this entire day. How do I get this fraction to be 1? I want to hear from new people, the Stephanies in particular. You turn in your card, Fiona. One of the Stephanies. How do I get t over 3.1 to be 1? What does t have to be? Either Stephanie, just go for it. No, not 1. 3.1. I want this to be 3 over 4, so I change t to 3.1, and it's 3.1 over 3.1, which is 1. Now it is going by 3/4 every 3.1 minutes. All right. Are there questions about today's lesson?
No.
All right. Go ahead and write a very quick summary. Maybe subtract 1 to get percent or something like that. And that concludes our lesson.